Welcome back to the deep dive. We've got a stack of material here, really comprehensive guide on Six Sigma, and we're going to pull out the key stuff for you.
That's a plan.
Today, we're digging into Six Sigma. Now, at first glance, you might think, okay, stats, factories, maybe a bit technical.
Yeah, it often gets that label.
But as we'll explore, the core ideas, they're actually super powerful and, well, they go way beyond just manufacturing.
Absolutely. Our mission today really is to cut through some of that jargon, unpack the fundamentals, look at the key methods, and see how Six Sigma is actually used out there.
Right.
The idea is to help you understand how these systems that can seem pretty complex can actually be analyzed and, improved, made much more predictable.
Okay, so let's start right there. If I want to get to the absolute heart of Six Sigma, what's the one core idea I really need to grasp?
The core idea fundamentally is reducing variation. That's it. The main goal is getting processes so consistent, so predictable, that defects just become incredibly rare. You're aiming for near zero.
Near zero. That sounds, well, almost impossible for some of the complex stuff people deal with. Why this intense focus specifically on variation?
Because variation, that's the enemy. It's the enemy of quality, of predictability. Think about baking, maybe.
Okay.
If your oven temperature swings like crazy, right? One batch, burnt cookies. The next, it's undercooked dough, even if you follow the recipe perfectly.
Yeah, been there.
Right. But if you reduce that temperature variance, make it stable, you get consistent, good cookies every single time. Six Sigma just applies that same thinking to any process. Manufacturing, services, admin. Less variance means fewer defects, less waste, and just, reliable, high-quality results.
So the less wobbly the process, the better the outcome.
Yep.
Got it. Where did this intense focus come from? Where did it originate?
Well, there's a really great origin story, actually, at Motorola back in the 80s.
Motorola. Okay.
Yeah, the CEO then, Bob Galvin, he laid down this huge challenge.
Yeah.
I mean, tenfold improvement in half a decade.
Wow, tenfold. That's
Yeah.
ambitious.
Hugely ambitious. And engineers like Bill Smith and Dr. Mikkel Harry, they were really central in developing this structured way, this methodology, Six Sigma, to actually meet that challenge. It wasn't just tweaking things. It was a fundamental shift in how they thought about quality.
A tenfold leap definitely needs more than just a tweak. So, okay, variation is the problem. How does Six Sigma actually provide a roadmap to, fix it? What are the approaches?
Right. So the methodology gives you these frameworks. Think of them as step-by-step roadmaps for improvement projects. The two main ones you'll usually hear about are DMAIC and DMADV.
DMAC sounds like an acronym. Let's start there. When would I use DMAC and what does it actually guide me through?
Okay, DMAIC. You use that when you're trying to improve an existing process, something that's already running but maybe isn't performing as well as it should.
Right, fixing something that's broken or inefficient.
Exactly. And the letters stand for the phases. D is define the problem, the goals, what the customer needs. M is measure the current performance, get the data. A is analyze that data to find the root causes. I is improve the process, implement solutions. And C is control the improved process, make sure it sticks, and the problems don't creep back in.
Define, measure, analyze, improve, control.
Okay. It's a really structured way to take a process from, broken to better and stable.
So if I'm, say, trying to cut down the time it takes to process customer orders or reduce errors in payroll, DMAC is the path.
That's the one.
What about the other one, DMADV? When does that one come into play?
DMADV is for when you need to create something totally new, a new process, a new product. Or sometimes, if an existing process is just so fundamentally broken, it needs a complete overhaul, a redesign.
Okay, starting fresh or a total rebuild?
Right. It stands for define, measure, analyze, design, and verify. So those first few steps, define, measure, analyze, they're pretty similar to DMAC. You're defining goals, understanding needs. But then instead of improve, you move into design, creating a whole new process based on that analysis. And finally, verify, making sure the new design actually works and meets the targets before you launch it properly.
Okay, so DMAC for fixing, DMADV for building or rebuilding, gives you a clear structure either way.
Precisely. And, as you start using these roadmaps, you realize pretty quickly how important certain core concepts are.
I'm guessing understanding what good or quality even means is like step 0.
Absolutely critical. Six Sigma really puts the customer front and center. You'll hear terms like the voice of the customer or VOC.
Right.
And from that, you figure out the critical to quality factors, the CTQs. These are the things that truly matter to the customer, what the process must deliver correctly from their perspective.
So it's not my idea of quality, it's theirs. How do you find that out?
Good question. It could be through surveys, uh, customer interviews, analyzing feedback data you already have, maybe brainstorming sessions with your frontline staff who talk to customers every day.
Okay.
The key insight is you have to measure your process against what actually matters to the person receiving the output.
So quality is defined by that customer experience. And if they're not happy, you've got a problem. Now, you mentioned defining the problem,
Huh.
and it needs to be specific. Why is that so important?
Because you just can't fix a fuzzy problem effectively. And you can't measure success if you don't know what success looks like, right?
Makes sense.
The source material had a great example. Instead of a vague goal like fix returns, you define it very specifically. The California Distribution Center had 15,000 returns out of 108,000 packages in Q1. That's a 13.8% return rate.
Okay, very concrete.
That number, that 13.8%, is measurable. It sets a clear baseline. And it makes the goal, maybe reducing that specific percentage, totally unambiguous. It stops the project scope from wandering and gets everyone on the same page about what done looks like.
Yeah, that makes perfect sense. It's not just make things better, it's get the return rate down from 13.8% to, say, 5%.
Exactly. And often, working alongside Six Sigma, you find lean thinking. Lean is all about eliminating waste, or MUDA, as it's called.
Lean and Six Sigma often go together.
They complement each other really well. While Six Sigma tackles the variation that causes defects, Lean goes after activities that don't add value. Think about types of waste like overproduction or wasted motion, the source mentioned, clicking between different software windows hundreds of times a day.
Oof, I feel that one.
Right. Or overprocessing, doing extra steps the customer doesn't actually value, like maybe complex packaging they just throw away. The source even distinguishes type I waste stuff that adds no value but might be needed right now because they're defects, like inspection versus type 2, which is just pure unnecessary waste.
Okay.
The insight is that reducing variation with Six Sigma often naturally exposes or even helps reduce that waste.
So Lean helps you spot the extra fat in the process. Six Sigma smooths out the bumps and errors and maybe trim some fat along the way.
That's a great way to put it. And of course, none of this happens by magic. Six Sigma relies on teams and specific tools.
Right, that's where the famous belts come in. Green belts, black belts.
Yep, those represent different levels of training and leadership within the methodology. A project team needs structure, and a really key tool for that is the project charter.
The charter. Okay, what's that?
It's basically the project's contract. It's a concise document that clearly lays out what's the problem, what are the goals, what's the scope like, what's in and out of this project, who's on the team, and who's the sponsor, the person championing it.
So it keeps everyone aligned and focused.
Exactly. It prevents misunderstandings down the line. And then the teams use various tools, often visual ones, to understand the process and the data.
Give me an example. What's a tool that helps you quickly see where the biggest problems are?
Oh, a fantastic one is the Pareto chart. It's built on the Pareto principle, yeah, the 80-20 rule.
Yeah, 20% of the causes lead to 80% of the problem, something like that.
Precisely. A Pareto chart is just a simple bar chart, but it arranges the causes of a problem, maybe types of defects, by frequency or impact, from highest to lowest. The insight is immediate. It visually shouts, "Focus here. These are the vital few causes responsible for most of your pain." It stops you wasting energy on the trivial many.
Okay, focus on the big hitters first. Makes sense. What about just understanding how the process flows in the first place?
For that, you use process maps. These visually lay out every single step in a process. Often they use standard shapes for different types of actions, like rectangles for tasks, diamonds for decisions.
Right, like a flow chart.
Exactly.
Yeah.
And the insight you get is often seeing steps you didn't even realize were happening, or identifying frustrating rework loops. The source mentioned a blog editing example. Mapping it out showed articles getting bounced back and forth multiple times between writer and editor.
Yeah.
Seeing that visually makes the inefficiency just jump out at you in a way that simply describing it might not.
So seeing the actual flow reveals those hidden loops and delays. Okay. What if you need a higher level view? Like, what's the overall scope?
For that high-level picture, there's something called a SIPOC diagram.
SIPOC.
Yeah, SIPOC. It stands for Suppliers, Inputs, Process, Outputs, Customers. It's a map, but at a much higher level. It helps define the boundaries. Where does this process start? What does it need to function? What does it actually do? What does it produce? And who receives that output? It's less about the nitty-gritty steps and more about confirming the overall scope and the key players involved.
Oh, Okay, so process maps for the details, SIPOC for the big picture boundaries. What about looking ahead, like trying to prevent problems before they happen? Any tools for that?
Yes, absolutely. That leads us to FMEA failure mode and effects analysis. This is a really powerful preventative tool.
FMEA, failure mode.
Okay. For each step in your process map, you basically ask, what could possibly go wrong here? What's the potential failure? Yeah. Then what would be the effect if that failure happened? What could cause that failure?
Okay. Thinking through the potential pitfalls.
Exactly. And then you rate three things: the severity of the effect if it happens, how often the cause is likely to occur, and how easily you could detect the failure before it gets to the customer. You multiply those three ratings together.
Severity times occurrence times detection.
Right, and that gives you a risk priority number, or RPN. The insight here is that it quantifies risk. It takes potential failures and puts a number on them, helping you prioritize which potential problems you should focus on mitigating first before they actually cause harm. The source had an example with a refund check defect, calculating the RPN to show which failure modes were riskiest.
That RPN sounds like a really clear way to decide where to focus your prevention efforts. So we've defined the problem, mapped the process, looked at risks. How does data really drive the analysis and confirm if fixes work?
Data is everything in Six Sigma. It's the absolute backbone. Decisions aren't based on, gut feelings or opinions. They are driven by evidence from the data.
Right.
And this is where statistical analysis really comes in. You often use software tools like Minitab or even things like the Analysis Cool Pack in Excel to do the heavy lifting with the calculations.
And there are visual tools for the data too, right? You mentioned process maps, but what about for analyzing the numbers? I think I've heard of histograms.
Yes, histograms are fundamental. They show you the distribution or the shape of your data. You collect data on something, maybe processing time, maybe error rates, and the histogram shows you how those measurements are spread out. They're clustered tightly around an average. Are they skewed?
Skewed.
Yeah, like the source example of call completion times. Maybe the histogram showed the data wasn't symmetrical. It kind of fell off sharply after a certain time point. That shape tells you something important about the process, maybe a hidden limit or constraint that just looking at the average wouldn't reveal. The insight is that the shape of the data often tells a richer story than just a single summary number.
It shows the reality of the variation, not just an average.
Yeah.
Okay. What if you suspect two things might be related? Like, does X affect Y?
That's where scatter diagrams or scatter plots come in handy. You plot data points for two different factors on a graph, say productivity on one axis and maybe training hours on the other.
Okay.
The source mentioned examples like productivity versus salary, or maybe errors per hour as output increases. You plot the points, and the visual insight is seeing if a pattern emerges. Do the points seem to trend upwards together? Positive correlation. Or downwards, negative correlation. Or is it just a random cloud of dots? No correlation.
So you can see if there might be a connection.
Exactly. But, and this is crucial, the source emphasizes that correlation is not causation.
The classic warning.
Right. Just because two things move together doesn't automatically mean one causes the other. There could be a third factor influencing both, or it could be coincidence. So a scatter diagram might point you towards areas to investigate further, but it doesn't prove cause and effect on its own.
Good reminder. Okay, so you analyze, you make an improvement. How do you monitor the process afterwards to make sure it stays fixed, stays stable?
That's the critical control phase. And the main tool there is the control chart. These are basically run charts, plots of data over time, but they have statistically calculated upper and lower control limits added.
Control limits based on the process itself.
Exactly, based on its natural inherent variation when it's running normally. The major insight control charts give you is whether your process is stable and predictable, operating within those natural limits, or if something unusual or unexpected has happened, what we call special cause variation.
Like a point falling outside the limits?
That's one signal. But there are other patterns too. The source mentioned one rule: 8 points in a row on either side of the center line. Even if none are outside the limits, that pattern suggests something has shifted. Maybe two different processes are accidentally mixed together. Control charts help you spot when a process is drifting out of control before it starts churning out lots of defects.
So it's like an early warning system for process health.
Very cool. And for digging even deeper statistically, you might use something like hypothesis testing. Correct. Hypothesis testing is a more formal statistical method. It's used when you want to make inferences about a whole population, say all your customers, based on data you collected from just a sample.
Okay.
The insight it provides is the ability to make conclusions backed by statistical probability with a calculated level of confidence. But it also forces you to acknowledge the risks of being wrong, like making a type I error, where you conclude there's a difference when there isn't, or a type 2 error, where you failed to detect a real difference. It's a rigorous way to test assumptions or confirm if a change truly had a significant impact.
Right. So from visually spotting issues with Pareto charts to statistically confirming impacts with hypothesis testing, Six Sigma gives you this whole data-powered toolkit. Now, we said early on it's not just manufacturing. How does this actually play out in totally different sectors?
Oh, it's fascinating to see how widely it's been applied. Take healthcare. The source mentions Virtua Health using Six Sigma to improve processes around cardiac medications. They were aiming to boost patient safety and also align with major national healthcare goals.
Yeah. Complex area. Challenges there.
Definitely. Things like strict hypo regulations,
Hmm.
the high sensitivity of patient data. It shows the methodology has to adapt, but the core principles still work in these really complex, regulated environments.
Okay, so healthcare. That's a world away from making widgets. What about, say, finance?
Yeah, finance too. Citibank actually partnered with Motorola pretty early on. They applied Six Sigma to things like reducing the time it took to complete financial processes, improving cash management for clients.
What was tricky there?
A key challenge was applying metrics and finding defects when you're dealing with intangible services, not physical products you can easily measure. But they reported significant gains in customer satisfaction and efficiency.
Right. Measuring service quality needs creative thinking.
Yeah.
What about somewhere really customer facing, like hotels, hospitality?
Absolutely. Starwood Hotels, they own brands like Westin, Sheraton, W Hotel.
Why, yeah.
They use Six Sigma quite extensively. Interestingly, not just for pure efficiency, but they framed it as driving creative innovation across their different hotel types. They trained hundreds of employees as green belts and black belts.
And the results.
Pretty stunning, according to the
Wow.
source. They reported achieving an additional $100 million in profits in just 1 year, directly from Six Sigma projects. A challenge they noted was dealing with the inherent uncertainty and variability in customer behavior and preferences in hospitality.
Wow,
Yeah.
$100 million is significant.
Huh?
Okay, and in the digital space, e-commerce.
Yep, even there. The source gave an example of eBay using Six Sigma principles to improve their pre-chat customer service survey. They analyzed the process and realized they were asking customers for basic info they already had repetitively and not getting key details needed to actually solve the problem efficiently up front. So they redesigned it.
Streamlining the customer interaction.
Exactly. And of course, in manufacturing, its birthplace, it remains foundational for things like spotting bottlenecks and driving down defect rates.
So really, whether it's patient safety, bank transactions, hotel check-ins, online support, or building a car, the core ideas of finding variation, using data, following a structured approach, they seem to hold true.
They really do.
What are some of the roadblocks then? If this is so powerful, what typically gets in the way when companies across these different areas try to implement Six Sigma?
Yeah, the source material points out several common hurdles. A really big one is just human resistance to change.
Always a factor.
Always. People get used to doing things a certain way, even if it's inefficient, and change can feel threatening or just like extra work. Another common one is lack of resources, not enough funding, or not enough people trained in the methodology to lead projects effectively.
Right.
Then you have industry-specific stuff.
Mhm.
Regulations like IPEA in healthcare or PCI DSS for handling credit cards in finance and retail add layers of complexity that projects have to navigate carefully.
Compliance is key.
Absolutely. Handling sensitive or confidential data properly is a huge concern across many sectors. And finally, in some industries like, say, fast food or parts of retail and hospitality, you have high employee turnover.
Hmm.
That makes it really challenging to sustain the improvements because new staff come in who weren't part of the change or trained on the new, better process.
Those sound like very real, practical challenges. It's not just about the stats and the charts, is it? It's
Yeah.
about managing change, dealing with regulations, keeping people trained.
Exactly. It's very much a socio-technical system. The people side is just as important as the technical analysis.
Okay. So wrapping up this deep dive then, Six Sigma, it came out of this audacious challenge at Motorola, but it's really evolved into this powerful, very structured, data-driven way to look at any process, to understand it, attack the variation within it, and ultimately get much better, more predictable results.
Yeah, it provides a toolkit, but also a mindset, I think. For anyone looking to make things work better, more consistently, with fewer mistakes, fewer frustrations.
It seems like a kind of universal language for improvement.
I think that's fair to say. Whether you're analyzing a huge manufacturing line or a call center script, or a hospital's patient admission process, or heck, even just your own personal system for managing emails.
Yes.
The basic concepts still apply. Defining the problem clearly, measuring how it's doing now, figuring out the root causes, trying solutions, and making sure they stick. It's a really relevant way of thinking.
Which leads us perfectly to a final thought for you, our listener, to maybe mull over after this deep dive. Think about a process you encounter regularly. It could be something on work, maybe a system you use at home, could even be part of a hobby.
Anything, really.
Right. If you were to put on a Six Sigma hat just for a moment and focus on reducing variation or defects in that process, what specific defects or inconsistencies jump out at you? What's the one piece of data you'd ideally want to measure first to really get a handle on the problem? And maybe most importantly, who is the voice of the customer for that process? What outcome or experience truly matters to them?
Yeah, just thinking through that lens.
Exactly. Consider how applying that kind of structured analytical thinking, even informally, might reveal some opportunities for improvement you hadn't really seen before.
Yeah.